Today we're going to continue moving right along in chapter 2. And, we could start out with a quick review of what we've been doing. And the thing I would pull up is I would go here and I would click on quadratic.java, program that we worked on last week. Oh, look how pretty and easy to read this is. Everything's indented. I have line spacing, some documents. There I declare all of my variables, A, B, C, root 1, root 2, and discriminant. This 19 through 21, right now I'm hard coding numbers in. Eventually, I'd like to be able to do input, and hopefully we'll get to that before the end of class today. We talked about creating a discriminant. We use these things called methods, SQRT, block of code stored in the math class, which is a collection of little blocks of code that all deal with math. And then, of course, we displayed what the roots were. Okay. More in the output, I should have put what A, B, and C were. I think I did in the version last week. Any questions up to this point? And it's funny, I know a lot of this we talk about is what the online students are asking questions about. And, I'm like, it's displayed in the video. It's displayed in the video. But, okay. So sometimes
What video are you talking about?
Oh, that's another thing I wanted to talk about real quick. So when I go share and I go share, not share the singer. If I go to share and I'm gonna stop sharing. Okay. Stop.
Was this the video you shared on Friday?
Yeah, I don't know how that got on there, so just ignore that.
Okay. I was like, it's a Monday, Wednesday class, right? We didn't have class today.
Right. Yeah, I don't know how it got on there. So I'm gonna come here for a minute. I'm gonna go to our D2L page as soon as there we go. And over here on the right side, I know you've gone up and down this page. You don't just ignore it and just use the toolbar here, the navigation bar. So you know where the Zoom link is. You know where these boxes are called widgets. Here's a widget, and some of you have used this to make an office hour already. Here are the classroom videos. There's sections 2.1, 2.4, which was last Monday. This one, 2.5 to 2.6, was last Wednesday. After we're done today, I'll put that one on. And then finally, there's a widget here at the bottom for calendar. Would you like these rearranged, or are you okay just knowing that they're there, that you can go when you need? Because I think Zoom is probably the most popular one. Belongs up top.
It's been working out for me so far, so I like it.
Okay. All right. So just so you're aware, Anthony, you said where are the videos? Right there they are of the classes. So the recording that I'm doing right now will be up probably an hour after class, if not sooner, if you need to rewatch it or if you're absent. Okay. And then finally, the calendar, you can look at what's coming up. Okay. So coming back to this chapter, chapter 2, we're going to hit 2.7 and we're going to start rolling and see how far we can get. Data types, I have 2 of them. I have X as an int, Y is a double. And we know I can give X a value of like 4. I can give Y a value of, for example, 2.5. And up here, I'm actually working with different data types. Here I'm trying to say, store 2.5 in an integer. How do you think that's going to work?
It's not.
It's not, right? Right? No, not applicable. No soup for you. It's not going to work. Up here, I'm trying to store 4 into a double. What's going to happen there?
It's going to turn it into a 4.0.
Excellent. Y is now going to have the value of 4.0. Okay. So when I go from bigger memory to smaller, it won't work. Because remember, we said ints were 4 bytes, doubles were 8 bytes. Doesn't work. Okay. If I want to go from smaller to bigger, I can do that. It'll convert it for me. Now, sometimes I want to do conversions, and I can do this thing called casting. And what I can do here is, well, remember y is a double, has the value 2.5. By putting parentheses in front of it, I can cast it. So now x is going to have the value of, I wonder what's going to happen if this casts it. It's going to turn 2.5 into an integer. What do you think it's going to be?
2.
2.
I assume it wouldn't round.
You are correct, Anthony. It will not. Oh, just a reminder. What's this one? What value does x get here?
2.
2. Good. Again, that's integer division. What do you think for this one? Turns it into a double. Divides it by 4.
2.5.
2.5.
Okay, 2.5. And then I'm going to try to store it in an integer.
X.
An
So
integer.
then it goes back to being
Back
2.
to 2.
Nope, it crashes.
Oh.
Just like this guy up here, not able to. Down here, I'm not able to. Okay. What gets stored in Y?
Wait, why is it that you can't do that?
Okay, so this
Like
becomes,
convert into a double?
okay, because I cast it and put the word double in front of the 10, it turns it into 10.0. 10.0 divided by 4 is 2.0, but I can't store, or excuse me, 2.5, but I can't store 2.5 in an integer. Just like I tried up here, I tried to store 2.5 into an integer and I'm not able to. No good.
Okay, so you can convert from double to integer, but not from integer to double.
No, you can convert them all. Depends where we're trying to store them. That's where the problem came in. What do you think the answer to this one is? What's y get the value of?
2.5.
Yeah, 2.5.
2.5, good. What about this one? What does y get the value of?
Um, 2.0.
Very good, 2.0. 10/4 is integer division, which gives me a 2. That's in parentheses, so that gets done first. After that 2, I turn it into a double, which makes it 2.0, and then I assign it to y. So really that double is almost ineffective. You notice I can put the casting anywhere. Here I'm going to cast the 4 first into a double. Again, y equals, same as up here, y is going
2.5.
to equal 2.5.
Okay, so I guess the takeaway here is you cannot store a double in an integer.
Correct. And again, up here, we were trying to take 8 bytes and put it in a variable that's 4 bytes. Good. Okay. So I'm creating variables, X and Y, and I'm using them throughout here because they get values and they can change. Well, what happens if I come down to something like what you see here? I create a variable, it's a double, okay? And what I want to do is be able to give this variable price a value and never let it change. I want to lock this variable in. Okay, so these are something we call constant variables, because what if I have a price and I want to use it throughout the program, and then all of a sudden I say, oh, the price just went up by 50 cents. Well, instead of having to change it everywhere in the program, I would only have to change it in this first line. Notice the naming standard here is to make these constant variables all caps. So we know that they're constant variables. And again, the word final locks it so nobody can change price within the program. Another example might be pi. What if I didn't want it? Well, we know we have math.pi, but this is just an example. What if I said pi equals 3.141592653589793? I don't want to keep typing that throughout my program. So I might pick a variable name, pi. The other day in the class, somebody put PIE for pi. I don't know if it was, I think it was this class. And then make it a constant double so that nobody ever can change it. Okay. So section 2.8, it's a really short one, but it talks about named constants. Okay. Named constant variables. Pretty easy. Do I use this when I code? No, I don't. But there's an option and you may see it, and that's what it is.
Professor.
Is the point to make it unchangeable?
What makes it unchangeable? The word final.
Final.
Yep, that we put out front.
And
So
why
what-
would you want to do that exactly? Because
Well, that means
I
wherever,
guess if somebody tries altering the code, then it just crashes.
right, if I tried to say price equals 6 down here, it'll crash. It won't let that happen. It won't compile.
So to make sure that somebody at a later point does not alter that variable,
Correct.
like if it's an important one.
Yep. Yep. Can I hear another question?
You answered it.
Cool. Good. Look at us moving right along. All right. So today we're going to learn another data type. I'm going to create variables like name that are going to be of data type string. And as you went through the code listings, hopefully you started to see this. Reminder, unlike int and double that were all lowercase, this data type called string is going to be a capital S. Like I said, unlike all of our primitive data, or guess I punched a hole in that spot. Yeah, so this is a capital S. The rest of them are going to be lowercase. Now, back in the day, string wasn't available. We had a workaround that didn't work so well. But as Java evolved and became bigger and bigger, somebody created this for us. It's not a primitive data type. Okay, so how does a string work? Well, I might be able to store something like George Washington. There's my double quotes again. What color is that going to be when I type it?
Green.
Green.
Green. Good, right? I'm going to store that in my variable called name. I'm going to be able to store that in a variable called name. Okay. Now, what is this actual string thing? How does it compare to something like num? I might have an int num. How do they compare? Okay, so int num is 5. Num will actually hold the value, right? We say, whenever I say int for num, I'm like, uh-oh, I need 4 bytes, cha-cha. Number is right here in memory, and it stores that number, 25, for example. Okay, it stores 25 right in there. Boom. I know it's 4 bytes. It's locked down to be 4 bytes. Now, string is a little bit different. When I declare the variable, I have to find memory space that's available. So the memory space that I use is going to be a little different. It's not going to hold the actual value. In this case, it's going to hold the memory of the address where the data item is going to be. And this is called a reference variable. All right, so what do I mean by that? I said number, 4 bytes, and I'm able to store it right in there. When I declare string, I don't know how long it's going to be. So when I declare it, I need to lock down a certain amount of memory. And I think in this case, it's 2 bytes. I'm probably wrong. And what I store in that 2 bytes is a location where I can start a string.
Is that location automatically assigned?
Yes, yes. So when I say string name, it comes and it finds a place where I can store it, but what's stored in name is just the address. So when I get ready to use it, it jumps over here because this is going to be dynamic. It can grow or it can shrink. Okay, it can grow or shrink. This I can't have grow or shrink. So that's why all I store in here is the address. This guy can't grow or shrink. He's 4 bytes and done. So we have a new data type called string. It's not one of our 4 primitive data types. Okay, it's not one of the 4 primitives, but what it does is it gets a certain amount of memory and stores an address of somewhere else that can grow and shrink depending on what I want to put in here. Now, this string is what we call a class. And if you remember from a little while ago, we said, it's not on this page, it was near the math is a class. And what do we mean by a class? It holds a bunch of little blocks of code that can do things like SQRT, like POW. So string is a class, and it holds a bunch of little blocks of code. It holds a bunch of little methods. And again, if you wanted, you could go and Google Java, string, class, methods, something along the lines of that, and you'll see there's a lot of them. And we're just going to take a look at a couple of them right now. So I declare a string name, and I come down here and I say, okay, I want to take that string and apply a method to it. Now this time, I'm not using the name of the class like I did with math. This time I'm using the name of, this is actually called an object. Okay, and you're going to see all this in chapter 5. So you're getting a taste of it right now. I'm going to say name, and I'm going to ask the length. So for this guy, length is going to get the value of, and if you remember, I said George Washington. Start counting George Washington.
$12? No, I think I miscounted.
Yeah,
Like
16.
17
I'm getting 17
with the space.
with the
Would it be
space.
18?
Right.
Oh,
with the
17.
No,
space.
16 because it starts at 0.
Well, now don't say that yet, okay? Right now, I'm just looking at the actual length, the real live length of this guy right here, okay? If we count up all the characters, including the space, you should get 17.
Yeah, 17.
All right, so now there's other things I can do, other methods. And the next method is something where I'm going to declare a character called ch. What do I mean by that? I'm going to go char ch because it'll be able to hold a character. I'm going to say, okay, let's take a look at that string. And what's the character at location 0? Well, as Anthony mentioned a moment ago, even though my string length is 17, the way you're going to see a lot of things work in Java and C++ is we start at 0. So if I say what char is at 0, it's going to be, char is going to get the value of, again, characters are single quotes, so it would get the value of single quote G. What's the character at position 0 of George Washington? G. What's the character at 5?
E.
Yep, the lowercase e. Okay, and again, when we're talking about characters, it's single quotes. When we're talking about strings, it's double quotes. What do you think this guy's going to do? 2 upper.
Make it
It's gonna make it
uppercase.
make it everything capital.
Everything capitalized, right? And you probably saw that.
Capitalized.
Was that in one? That was in one of the code listings, if I remember correctly.
Yeah, it was, yeah.
Yeah, and there's a good example of it. You know, the big one, length is huge, and charat is huge. Those 2 methods you're going to use quite a bit throughout the course. So they're ones we definitely want to draw attention to them, and I want to make sure you understand them. But there are other, like 2 uppercase and on and on. If there's a 2 uppercase, you know there's going to be a 2 lowercase. Do you notice how the methods are all written in Camel Case? In Camel Case, okay? The first character is lowercase. Every word after that, the first character in that word is uppercase. It's a nice, convenient naming standard. when you write methods later down the road, you're going to be able to name them whatever you want. I'm hoping that you follow the naming standard. Questions? Good. Let's keep going. Let me share my screen, and I'm going to pull this up again. And section 211 talks about documentation. Okay, documentation. So let's see what we have up here as far as documentation. Well, some of you already know that the slashes make a line orange, and it's documentation. Another way to do the documentation is to start with a slash asterisk and to end with a asterisk slash. Okay. And a lot of you are starting to do a pretty good job of, so I wouldn't even really need these, but you're starting to do a pretty good job of putting comments in here. And you need to put in your name, you need to put in the date and all of those things that talk about the program. And a time will come where you're going to look at that and go, oh, okay, all of that makes sense. Why I need to do this. Or you're going to be saying, thank you to the person who wrote this program and documented, because it makes it really easy for me to understand. Okay, moving on. Finally, we're going to get to something good. Section 213. Going to take a look at it by pulling up a little program. And let's see, what do I have? I'm looking at a way to do input. Finally, I can do input. This isn't too bad. All right. So in order to do input, the way we're going to learn it, and there's other ways, this input is going to be input that I'm going to do down here in the console window. Again, this is the console window is for programmers right now. On Wednesday, we're going to look at GUIs, and that's how you're going to be writing everything after this, so that your input is more user-friendly. Your output will be more user-friendly. But for now, we're still doing stuff down here in the console window, which is great for programmers. All right, so I want to set up a way to learn how to input. I'm going to take a look at what's going on in this program. First thing is this line number 5. So if I want to do input in the console, I need to import this. Oh, there's that word class again. And what that means is I'm importing some from this class methods that I'm going to need to use within my code. And these things called objects. They're like variables, but again, don't worry about them. I'm just giving you the lingo. All right, so line 5 is one that if I want to get ready and read something from the keyboard for input, I need to import java.util.scanner. Okay, so that's the first new thing. Line 7 looks like I'm calling this input and output. And after that, 8 and 23 go with that. Then I have my ever popular public static void main string args. And I have line 10 and 22, which are the braces to go with it. All right, line 12. Line 12, I have string name. Okay, good. We just learned about strings. The second line that is of importance, there was a highlight function. I'd highlight 5 and I'd highlight 15. Okay, second important line. 15 says, hey, I want to be getting stuff from the keyboard. And in order to do it, I need to create a variable. It's actually called an object. And I'm creating this one. It's called keyboard. Creating something called, you could name that anything you want. We're not using it that often. Leave it as keyboard. Okay. So when I come down here, I say, hey, what is your first name? And all of a sudden I'm going to say name, which is a string, equals keyboard dot next line. So that's saying, okay, the next line I type in is going to get stored in the variable name. And then I can display it. So with a little luck, with a little luck, sometimes I feel like I'm lucky, I'm going to compile this. What is your first name? Again, notice we're working down in the console. Big Bob. Okay. And when I hit enter, good morning, Big Bob. You notice when I did my input, I did a system.out.print so that when I typed, it went right beside it, made it look a little nicer. But I am able to input an entire line and store it in a variable called name. Say cool beans. I'm going to create cool beans. I'm going to create another variable, int age, age. I'm going to come down here and I'm going to say, all right, I'd like to know what your age is. System.out.print. What is your age? Age, question mark, space, double quote. Age equals, again, I'm going to grab something from the keyboard, dot next,
Int.
int. Very good. Again, it's Camel Case, int. Yeah, so depending on what I want to input from the console, I'm going to do next, whatever that example is. System.out.println. You, how about this? Really? You are only double quote, space, plus, space, age, years old, exclamation, exclamation, double quote, parentheses, semicolon. Nice user interaction. So when I wanted to input something and store it into a string, I use next line. When I wanted to input something and store it in a different variable, like an int, like a double, so on, I could input this way. Does anybody think this will run? Now, what is your first name? Big Bob. What is your age? Well, you all know me, I'm 40. Good morning, Big Bob. Really? You are only 40 years old? Cool. Cool. Now, one of the things I'm going to tell you folks, and it may not be this time, but there may be a time. Traditionally, I'll have students that will grab their camera and take a picture of the screen if they need to, because they want to have that instant satisfaction. Or we'll do a quick print screen so they can save it and look at it. That kind of idea. All right. Well, what I'm going to have you folks do is come back to your quadratic program. We're going to change this to input, because that's no longer part of my processing. We're going to call this all the processing because this is where all the work is done. And we're going to change this to inputting my 3 numbers. So what is it I'm going to have to put in this program? I'm going to have to put in the import java.util. I'm going to have to put in scanner keyboard next keyboard. And then I'm going to have to do system.out.print. Please enter a value for A, then do it for B, then do it for C. So it looks like there's about 8 lines. All right. Instead of going into groups, hopefully you still all have your quadratics. You're able to grab it. And while you're working on it, I'll edit this one. That way you can compare if you got it or not.
So we're altering our quadratic project.
Yep, because we're going to keep adding the quadratic as we go through this semester. Yep, we're going to keep adding. So go grab yours. I don't know if anyone put it on the discussion board or not, in case somebody forgot it. but that's what we're gonna do. I'm gonna-
I never got the quadratic thing because the day we were doing that in class, I was not able to be on my computer. I was on my
Okay.
phone in class.
oh, that's not me. Did anybody put it on the discussion board?